Hello and welcome back to Zig's Math Lessons. I am your host, Ziggelviet B. Stunk. At this channel, we learn to become the best science, technology, engineering, and mathematics students for miles around. I'd recommend that you watch these videos with pencil and notebook handy and maintain the policy that if it's in the video, then it goes in your notes. Now let's begin. Recently, we looked at what a function was, and we determined that a function was a set of ordered pairs such that for every x there was only one y. We're going to look at function notation, the notation that math people made up to go with this idea. And this is basically it right here, y equals f of x. It means that y is the result of applying the function to some input x value. In fact, we could think of a function as a machine that makes ordered pairs, kind of like a machine sitting on a factory floor. Let's take a look at this. There's a box, and there's an input station and an output station. And what we're going to do is we're going to take this function machine and we're going to input or feed it x values. Now you have to remember that the input to the machine are the x values here. This particular function has a defining equation, so this is what it's going to do to the input. We feed it an x, it'll take whatever we feed it, square it, and add 3. So this is called the defining equation. And the result will be the y value. So if we plug in an x, it's going to do something, and it will output a y value. And that y value has a notation associated with it. It's called f of x, the result of applying the function to the input value. So let's take a look at how this works. If I fed it a 2, the output would be a 7. So we could say that f of 2 equals 7. And 2, 7 is a member of the ordered pairs that make up this function. If we fed it a 3, it would output a 12 because it squares it and adds 3. And 3 squared is 9 plus 3 is 12. So f of 3, in other words, applying the function to 3, results in 12. F of 3 is 12. So 312 is one of the ordered pairs associated with this function, and we can go on and on. We could feed the machine really anything. We could feed it -2, we could feed it pi, we could feed it -15.7, but I've just fed it a few things here, and let's see what happened. Feed it a 4, out comes 19, so f of 4 is 19. And so 419 is one of the ordered pairs associated with this function. 5 squared plus 3 is 28. Feed it a 5, it outputs 28. So f of 5 is 28, and 528 is one of the ordered pairs. Feed it a 6. 6 squared plus 3 is 39. So f of 6 equals 39, and 639 is another one of the ordered pairs. And I just concluded with ... because there's an infinite number of things we could feed this function machine to generate these ordered pairs. And in every case, what we're feeding it is an x value, and what it outputs is a y value. And that y value is called f of x, the result of applying the function to x. So the input of the function machine was the x value, while the output was the y value. F of x equals means the same as y equals for a given x value. So once again, suppose there was a function without a machine drawn, because that's usually not the way it's presented. But suppose you were just told f of x equals x squared plus 3, and you wanted to find f of 2. That means input 2 right there. So we would say f of 2 equals 2 squared plus 3, and do the math. It's very simple. So 2, 7. And if you ask for f of -1, it means input -1. This is what this is saying, input -1 into the defining equation. So we would say f of -1 equals -1 squared plus 3, and do the math. It's pretty simple. Minus 1, 4 is one of the ordered pairs. Let's move on with a different function. Now the beauty of this is we can make up many different functions and call them f of x. So in a different question, we'll have a different function. And here's another question where f of x equals x squared minus x plus 3. And we're asked to determine f of 2 plus f of 3. Let's first find the result of inputting a 2 to the function. So we'll input 2 right here. So 2 squared minus 2 plus 3. That's what I've written. Doing a little bit of math, it turns out to be 5. Similarly, for f of 3 equals 3 squared minus 3 plus 3, and that turns out to be 9. So f of 2 plus f of 3 is 5 plus 9. Right here, 5 plus 9, and of course that's 14, and that's f of 2 plus f of 3. I'd like you to notice that f of 5 is the result of inputting 5, and so we would say 5 squared minus 5 plus 3, which is 25 minus 5 plus 3, that's 23, and that's not the same as 14. So we can conclude that f of 2 plus f of 3 is not equal to f of 5. And the reason I bring this up is because I don't want you to think that we can just do arithmetic here and go 2 plus 3 is 5, so f of 2 plus f of 3 should be f of 5, but it isn't. We must do these separately. Oftentimes you'll be presented with a graph and asked to look at the graph and say, what is f of 2? So the graph is f of x. Y equals f of x. So to find f of 2, we need to input 2 to this graph. That means go to 2 on the x and say, where's the y value? Well, the y value is 8. And so f of 2 is 8. Again, f of 4 means go to input 4 to the curve, go to 4 on the x value, and say, where is the y value? It's up here at 12. So we would say f of 4 is 12. Let's play this game a little bit more. Here's another curve. F of minus 1 means go to minus 1 on the x-axis and say, what is the y value associated with that? The y value associated with that is, we can see here, 3. F of 0, go to 0 on the x-axis, go to where the function is with an x value of 0, and we can see that it's at 2. So f of 0 is 2, and we can read this graph this way. F of 1, go to 1 on the x-axis, there it is. What's the y value there? It's 0. Okay, let's start doing some algebra. What can you do with these functions? Well, we can do algebra with them. Suppose you were given in a different question that f of x equals x squared minus 3x and g of x equals 2x plus 1. One thing that this function notation is good for is the fact that we can have several functions in play at the same time. We could have an f of x and a g of x and a p of x and a q of x. With the notation, we can get different functions in play at the same time. And in this question, we have an f of x and a g of x. So we'll start by finding g of 3x plus 2. Okay, solution. First write it, and now realize what the plan is. The plan is to input 3x plus 2 into this, let's call it the g function machine. So we're going to input 3x plus 2. I notice that g of x is 2 times something plus 1. So it's 2 times something plus 1. So the input will go here because it goes where x is. That input is going to be 3x plus 2. So we'll put 3x plus 2 right there. And that's the hard part. The rest is pretty easy. It's from previous grades of math. Simply multiply 2 times 3x and 2 times 2 and add 1. And we get g of 3x plus 2 is 6x plus 5. Another example, given the same two functions, find f of 3x minus 2. Solution, first write it, and then realize, okay, we'll go to the f function machine and input 3x minus 2. So the f function machine appears to be something squared minus 3 times something. So we could set it up like that. It's something squared minus 3 times something, and the something is the input. 3x minus 2 has to go into the machine, so to speak. So there it goes. It's going in. There it is. 3x minus 2 squared minus 3 times 3x minus 2. And the rest is really grade 10 math. It's just a matter of squaring a binomial here. We have to square this and then subtract minus 9x plus 6 when you distribute the multiplication of the negative 3. And so let's work on this. The next line could look like this, and it would look like that because when you square a two-termed expression, this is a two-termed expression being squared. When you square a two-termed expression, you always take the first term and square it, so 9x squared, double the product of the terms, so this would be minus 6x doubled, which is minus 12x, and then add the square of the last term, which is 4. Just showing you that this is true over here in rough. Take 3x minus 2 and multiply it by itself, because that's what squaring means. And we would get 3x times 3x, which is 9x squared, 3x times minus 2, which is minus 6x, and then minus 2 times 3x, which is minus 6x, and then minus 2 times minus 2, which is plus 4. Collecting these two like terms here, and it results in 9x squared minus 12x plus 4, which is what this is. And then minus 9x plus 6. And it's just a matter of collecting the like terms, and we can make this statement. F of 3x minus 2 equals 9x squared minus 21x plus 10. Again, let's have some more fun with these two function machines. Let's find f of 5x minus 1 minus 2 times g of x plus 3. And we're starting to rock and roll a bit with it. First, write it. Then we have to go to the f machine and input 5x minus 1 into the f machine. Okay, well, we know the f machine is something squared minus 3 times something. Something squared minus 3 times something is going to go here. And the something is 5x minus 1, because we were asked for f of 5x minus 1. So it will go into the f machine. Now this says minus 2 times the result of subbing x plus 3 into the g machine. So minus 2 times g of x plus 3 will have to go in these square brackets. G of x plus 3 will be 2 times something plus 1. So we could set it up like that, 2 times something plus 1. And what's the something we're going to input? We'll input the contents of that bracket, x plus 3, right in there. And now it's a question of, can we expand all of this and simplify it? Well, here we go. Notice, when we square a two-termed expression called a binomial, we get these three terms. When we square that, we get this. 25x squared minus double the product minus 10x plus 1. And then what I did was I expanded minus 3 times 5 is minus 15x plus 3. And I saved this multiplication of the 2 times this square bracket. I saved it till the next line. Meanwhile, inside the square brackets, it's 2x plus 6 plus 1, 2x plus 7. And now expanding into the bracket, minus 4x, minus 14 right here, and meanwhile, minus 10x minus 15 is minus 25x, and plus 3 plus 1 plus 3 is plus 4. Collecting like terms, doing basic algebra from previous grades of math, we can make this statement. Other games we can play with functions. Let's find an x such that f of x equals 28. Solution. Method. Set this function f of x equal to 28 and then solve. Okay, well there's the function x squared minus 3x and equal that to 28. And now it's grade 10 because it's a quadratic equation which we will equate to 0 by dragging this 28 across this equal sign, which will change its operation from positive to negative. And then factoring. Of course, it's a quadratic equation. We could use the quadratic formula, but factoring is sometimes easier. So to set up the factoring, we set out the two factors to factor a quadratic, and then just like this, we leave blanks here. Leave a blank, leave a blank. Now, in the blank, we'll put positive whole numbers. Two positive whole numbers that multiply to 28 that are different by 3. And that's 4 times 7. 4 times 7 is 28, and they're different by 3. And now it's necessary to put signs on the 7 and the 4, pluses and minuses, etc. And the idea is that we get to minus 3 on a number line. So plus 7 minus 4 gets us to plus 3 on the number line, but minus 7 plus 4 gets us to minus 3 on a number line. So we can now conclude that x equals 7 or x equals negative 4. And we have found x's such that f of x equals 28 when x equals 7 or x equals minus 4. A last example where this might be used in real life. Air temperature decreases by a degree for every 500 feet of elevation. So those planes that are flying around at 30,000 feet, the air up there is really cold. If air temperature is 12 degrees at the ground level, express air temperature T as a function of height h. Okay. To get started, we'll say T of h. Kind of reminds you of f of x. What this is saying, mathematically, is the temperature for a height h. Okay. Well, let's see. We just have to build a function. It's 12 degrees if we don't go up in the air at all, because it says it's 12 degrees at ground level. But then as we go up in the air, it gets colder. Air temperature decreases. See this word decreases? That means we're going to start with 12 and start to go down from there. That's why we put a minus sign. And now it goes down 1 degree for every 500 feet of elevation. So we'll have to take the height and find out how many 500s there are in the height. Like if a jet was at 30,000 feet, we'd have to find out how many 500s there was in 30,000. So we'll have to simply divide the height by 500. And there it is. This is a function where when we input h, we would input h, the output will be T of h, the temperature at that given height. We say T is a function of h. I'm Ziegelviet B. Stunk. Thanks for watching. If you liked it, leave a like. If you like the content, please subscribe. Check back later for updates and new videos. I'd suggest you go over this again and make sure that you've written down all that algebra we did. And if you can clarify that to yourself, then you're well on your way to mastering this subject. Thanks and have a great day.